Now here question is, find the coordinate of the point which divides given points internally and externally. It means in 10th standard you have studied in coordinate geometry one formula, that is a section formula. What it says, that formula you have studied for 2D geometry. Now we are going to study 3D geometry. So first of all, before solving this question, let me introduce you what is a section formula in terms of 3D geometry. So suppose you are having 2 points, let A x1, y1, z1 and B x2, y2, z2 and R be a point which divides AB internally in the ratio m/n. So that time how its diagram will look like, observe here. A point, B point. Internally you are having a point R which divide it into the ratio m and n. This points be x1, y1 and z1 and this point is x2, y2 and z2. So here point R is equals to, you may observe, mx2 cross multiplication plus nx1 upon m plus n, comma ny2 plus ny1 upon m plus n. Till here you have done in 2D geometry. Now we are doing 3D geometry. So just one step further, that is one more coordinate, that is mz2 plus nz1 upon m plus n. Now in place of dividing AB externally, internally, suppose it will divide externally. Suppose we will divide externally. So that time, how its diagram will look like? Here, this is segment AB and somewhere you are having external point R. Now it is dividing externally, so this whole distance is m and this is n. These points are x1, y1, z1. These are x2, y2, z2. So that time your point R will be C. Same thing, mx2, but it is dividing externally. So from this distance we have to subtract this one, minus nx1 upon m minus n. Previously while we were doing internally, so that time we were doing addition. Here we will do subtraction. Remaining all things will be as it is. So ny2 minus ny1 upon n minus n. Last is mz2 minus nz1 upon n minus n. So these both formulas you have to remember. Now we'll solve this question here using your section formula. See. Now find the coordinates of the points which divide a line segment joining these 2 points. Let these points be A, minus 2, 3, 5 and this point B, 1, minus 4, 6. Internally, so let C be the point. This is a ratio. So here point C is equals to, you have to write down that let C be a point which divides AB into the ratio 2:3. Internally, this thing you have to specify and then after you will do calculation. So here point C is equals to, C, cross multiplication, 2 into 1 plus 3 into minus 2 upon 2 plus 3. Again cross multiplication, 2 into minus 4 plus 3 into 3 upon 2 plus 3. As it is same, 2 into 6 plus 3 into 5 upon 2 plus 3. You just have to remember, we have to do cross multiplication. While we are finding x coordinate, we have to multiply x coordinate. At y coordinate place, we have to cross multiplication of y coordinate. Just that thing only we have to remember. So which is equals to 2 1s are 2 minus 6 upon 5. This is minus 8 plus 9 upon 5. 12 plus 15 upon 5. So which is equals to, here we'll get, so minus 4 by 5 comma 1 by 5 and here 5 plus 2 7 1 plus 1, 2, 27 by 5. Okay, correct only. Now we have to find out for externally. So, here we will write, let C be the point which divides A and B externally into the ratio. You have to specify this thing, 2:3. So that time its diagram will change here. See, here we are having point A, B, and this one is external point which I have assumed C. Now this is 2 point and this ratio is 3. Now coordinates A are -2, 3, 5 and 1, -4, 6. So here point C is equals to same thing but with the negative sign. So 2 ones are 2, minus of this formula, minus 2 3s are 6. So minus will be plus 2 minus 3. Comma, here also cross multiplication, -8 minus 9 upon 2 minus 3 upon comma 6 2s are 12 minus 15 upon 2 minus 3. So which is equals to 2 plus 3, sorry 6 plus 2, 8 upon -1, minus 17 upon -1 here, -3 upon -1 which is equals to, will get -8 comma 17 comma 3. So these are the required vertices. Hope this solution understood to you. You just have to remember that same formula, but be careful, while externally given, in place of addition you just have to place minus.